to practice. So you'll have everything. Don't you worry. You're going to do amazing. Now, this question focuses on rates. The reason why I did a question on this is because I know that rates every semester, it's something that students tend to struggle with because it's kind of like, I think it's not explained the right way. And thankfully, in the little mock exam thingy that I got for y'all, that you'll have tomorrow morning, it'll explain it even better, like really step by steps, and it's interactive. You can like play with it so much that you'll see everything. But today I'll try to kind of give you some exposure as well. Okay, so we're going to do A, B, C, and D. They're all effective rates, quoted rates to APR, EPR to EAR, blah, 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 just to give you some exposure. Okay, we'll do them fast. We'll try to run through them just because we have bigger fish to fry, if that's a saying. Okay, so an interest rate compounded twice a year. Okay, compounded twice a year yields an effective annual rate of 5%. This is equivalent to what APR compounded daily? All right, so this one's interesting. So the first step to do is to understand, well, what the heck are we even looking at right now? All right. So the simple step to understand right now, okay, it's really straightforward. We know that technically, and if you guys look into your into the documents I gave y'all, we know for sure, okay, that the effective annual rate, right? We know for sure that the effective annual rate typically is equal to 1 plus QR over M to the power of M minus 1. So far, so good. Yes or no in the chat. Have y'all seen this formula? Yeah? 100%. Okay, that's really good. We can actually just work with this formula and get our answer. So what we'll do now is we notice that in the question, highlighted in red, they gave us our EAR. Okay, that's awesome. And they also gave us what we're looking for, essentially, in terms of like our M, right? They said we want an quoted rate. So we want a quoted rate, right? That's compounded daily, like this. So what we can do, okay, what we can do is simply just plug everything back into our formula, but working backwards. All right, so let me give you an example. What you could do, and I'll put it in blue, is say that 5%, right, is equal to 1 plus a quoted rate over 365 to the power of 365 minus 1. So effectively, what we're doing here is we're solving for x. That's exactly what we're doing here. We're just solving for x. So what you could do is simply either plug this in within a calculator or find different ways of going about it. And you could solve, like if you were like me and you had this calculator, you could actually do it immediately through it. Or you could try to like do some math. So for example, we know now that we have 1.05% is equal to, whoops, 1 plus x divided by 365 to the power of 365. Then you could do this 1.05% to the degree of 365. That's going to give you 1 plus x over 365. And then whatever this amount gives you here, minus 1, is going to be equal to x over 365. Then whatever you had here times 365 would be equal to x. All right. Can somebody tell me what is x? Because obviously I know the answer, but if you want to try it out, somebody try to follow these steps and solve for x, because this is something that you may have on your exam. It's pretty important to know how to do. This is actually coming from a past exam. But in the meantime, while you guys do that, I would like to add a other point that's pretty important. Because I saw all of you talk about it in the group chat, and I would like to just kind of shed some light on that topic. What the heck is a quoted rate? Okay, And I think there are a few rules to share when talking about this notion of the quoted rate. A quoted rate is always a yearly percentage. Okay? They're always going to give you a yearly percentage. The only factor that could change is the compounding periods. Okay? So, for example, if they give you a quoted rate of 8% and they say it's compounded daily, then it just so happens to be also your effective annual rate. But if it's anything other than daily, then you need to use the formula that we have here to solve for your effective annual rate. I hope that's a quick little spiel on it. Walid and Marianne, you guys are absolutely awesome. Thank you so much for solving that. And yes, the answer here is 4.88%. Now, before we go into B, is everybody okay with that? Marianne, Walid, Yusra, awesome. You guys are killers. Like awesome, awesome, awesome. Are we okay with that? Did the feedback on quoted rates help a little bit? Hopefully it did. But that's essentially the kind of the rule of thumbs. Now, if you look at the documents that I sent y'all, okay, I also gave you literally the formulas you need for quoted rates. If you don't need to use all of them, but they're pretty useful. So you may want to add them to your cheat sheet. Okay, so now we have 8%, all right, compounded semi-annually. And we want to know that's equivalent to what percentage compounded monthly. Okay, we want to know that's equivalent to what percentage compounded monthly. So a few things to do. As per usual, it's always to define the variables that we have here. In this case, 8%. Is it a quoted rate? Yes or no? Is 8% our quoted rate? Yes or no? Is 8% our quoted rate? Is it 8% this amount right here? Yes, it is. The number that they give you a number like this, followed by compounded something. You know that this is your quoted rate. So now our quoted rate is 8% compounded semi-annually. So twice per year. Okay? As simple as that. And we want to know that's equivalent to what percentage compounded monthly. Okay? So this is equivalent to what percentage compounded monthly. We want to know that. So the best way to go about this, okay, is actually pretty straightforward. You could actually use a very simple formula that I believe is honestly my favorite. You could go by simply doing the following. So when you're looking, and I'll write it here in blue. All right. When you're going from one rate that's compounded at a certain frequency to another rate that's going to be compounded at a certain frequency, you must use this formula. Okay? Please, when you're going from one rate compounded at a certain frequency other than daily to another rate compounded at a certain frequency other than daily, you must use the following formula. I hope it's clear at this point. And I'll say it again once we finish the question. But when you're going from one rate compounded other than daily, you really want to use the following formula. Okay? You want to use the following. 1 plus QR over M, power of MF minus 1. Now, don't forget that M is your compounding periods, and F is the number that you're kind of seeking, the number of compounding periods that you're seeking. Okay. So I guess we'll write it on the side here. So actually not even, we'll write it just at the bottom. So in this case, what you would do is you would do 1 plus 8% divided by 2 to the power of 2 over 12 minus 1. Can somebody tell me what that gives us in the chat? Okay, so that gives you essentially 0.6558%. All right, that gives you an amount that's obviously way too small, right? That's obviously not our answer. What you need to do once you find that amount, okay? Once you find essentially your effective periodic rate, in this case, your effective monthly periodic rate, if you want to find essentially the annual rate for this one, all that you got to do is take this amount and multiply it by 12. So, Yusra, if you take that amount and multiply by 12, what do you end up getting? Because this is our effective periodic rate. So what would this be equivalent to per annum? It'd be equivalent to 7.8698% overall. Now, a few things to note when it comes to this question. I get it that I think in terms of wording, it's not the best, but what they want to know when they say something like 8% compounded semi-annually is equivalent to what percentage compounded monthly, it goes again with the idea that we're looking for what's the quoted rate, the annual quoted rate, compounded monthly. So in this case, what you would need to do is you need to first and foremost solve for your rate on a monthly basis, right? You take the number that was provided, then you bring that to its monthly basis, right? 0.658%, something around those lines, is obviously way too small to be an annual quoted rate. So in this case, you multiply by 12 because we have our monthly number. So you're going to multiply by 12, and that's going to give you your annual quoted rate compounded monthly. All right, are we good so far? Does this question make sense? Like, would you know what to do? Yes, no, peut-être, confused? Okay. This is another question that you may see on your exam. This one's pretty easy, not gonna lie. There's actually a trick that you could use to make this simpler for you, okay? So there's a trick that we could use to make this a little bit easier for us when we do such a question. So on an exam, they may say something like this, okay? They may say, which of the following investments provides the highest effective annual rate, okay? In this case, we have 9%, which is essentially the quoted rate, compounded semi-annually, right? Here we have 9%, which is the quoted rate, compounded monthly, okay? And here we have 8.9% with quarterly compounding, okay? Now let me ask you this. The more compounding periods we have, the higher our effective annual rate. Is that true or false? The more compounding periods we have, all else being equal, the higher our effective annual rate. Is that true or false? Somebody tell me in the chat, is that true or false? It's true. It's 100% true. Because essentially, what we're telling you here is that if you have 9% with semi-annual compounding, if you were to break it down onto a timeline, what they're simply saying is that we could have this being t equals 0, t equals 1, t equals 2. What they're saying is that you're getting 4.5% here on your money, and then 4.5% here on your money. right? So you're compounding twice per year. Whereas in the other scenario, we're telling you, you know what? We're going to compound your figure every single month. 4, 5, 6, 7, 8, 9, 10, 11, 12. So each month, you're going to get compounding, right? So you're going to get 9/12 each month. So you're getting much more compounding periods. You have much more opportunity to build interest. So for that reason, it's obvious that the more compounding periods you have in a year, the higher your effective annual rate, right? The more compounding periods you have within the year, the better opportunity you have to build interest. And in that case, it's obvious for sure that number 2 right here is better than number 1, okay? And usually on an exam, when they give you a smaller percentage, it's very rare that that's going to be the answer. Just because it would take a lot of compounding periods for 8.9% to be bigger than 9% compounded monthly. All right, so usually the rule of thumb on the exam is to choose the biggest percentage with the highest compounding periods. So in this case, number 2 would be the answer, okay? But if you were to be unsure, because sometimes they can be tricky, you could also compare essentially the highest the highest compounding my god, sorry. You could compare the highest compounding period number for each percentage and then compare which one's the biggest one. In this case, it would be number 2, but in some exams, it may be relevant to do both. Okay, just to be sure, because you never know. All right, so to double down on the rule is you want to look for the highest quoted rates. And then once you find that, you want to look for the highest compounding periods. That's going to be your answer for the highest effective annual rate. Okay? If you are, you want to be sure, you could definitely do that for all of the percentages provided. So if you're given, like in this case, 9% and you were given 8.9%, you would look for the highest of both percentages if you were given multiple like options, then you just compare the two. Okay? For this question, are we good? Does that make sense? Yes or no? Yeah? Okay. And for question for D, give that a shot. This one's pretty fun as well. So this one, it's very important to know what to do. I'm sorry, I'm just trying to get to the harder questions because they're important. But yeah, so given a 24% annual periodic rate, compounded every 5 years, okay, what is the effective quarterly rate? Now, this is interesting. Now, if y'all remember before, I'll write this in red. If we're going from a undaily compounded type of thing, so if we're going from anything that's not compounded daily to another thing that's not compounded daily, we need to use just one formula, okay? We need to use one awesome formula. In this case, we're going to use, if you guys remember, something that looks like this. -1, okay? But in this case, I think it's important to really do it together because we're going to have something that looks like this. We're going to have 1 plus 24% divided by 5. But the exponent's going to be very interesting because our m, right? Actually, m is going to be 1/5. Sorry about that. Right? Let's actually begin with that part. Can everybody tell me if they understand why our m is actually 1/5? Does everybody understand why our m is equal to 1/5? Can everybody say yes or no in the chat? like Waleed, Shane, what's up? Do you guys understand why it's m equal 1 over 5 and not m equals 5, for example? Yeah? Okay, you guys are solid. Yeah, you guys are awesome. Okay, yes, m 1 over 5 because we're compounding for essentially once for every 5 years. Okay? So you guys are awesome. Very good. If you have a question, write it in the chat though. Let me know. But then here we would have essentially m over f. We know that our m is 1 over 5. However, we're going to put that over our f. In this case, can somebody tell me what is our f? What is our f? What is our f? Exactly. F is 4 minus 1. So could somebody tell me then, what is our effective periodic rate? This case, effective quarterly rate. If you know all of these different numbers, what is our effective quarterly rate? You guys are awesome. I want to say something really cool. Up until now, you guys barely, like, low-key made no mistakes. Like, that's really, really cool. For sure, you're doing it with me, and we're in a group. But like, that's really good news. You guys are catching on to everything, and I'm extremely proud. So we're doing really well. Just overall, congrats to everybody. These are questions that students mess up all the time, like all the time. So it's very good, that you're able to get it. So I'm very proud. Okay. So